It's a living, breathing system packed with these intricate relationships. Every single plant, every animal, even the stuff that isn't alive, like the soil and the sunlight, they're all interacting in this kind of delicate dance. And that right there, that's exactly what an ecosystem is. It's the whole community of living things in the spot, plus all the non-living things they rely on and interact with. It's the entire picture, not just the individual puzzle pieces. And here's what's so cool. These interactions go way beyond a simple food web. It is not just about who eats who. You've got Jilla woodpeckers carving out a home for themselves inside a giant saguaro cactus. Cactus wrens use spiky cholla as a natural fortress to protect their babies. The plant roots are literally holding the ground together, and the animals are paying them back by spreading their seeds. It's this incredible network of give and take. And this is the really big idea here. These complex connections, they aren't just a desert thing. They are the fundamental rules of life itself, and they apply everywhere, no matter how extreme or different the environment might look. I mean, just look at this contrast. It is night and day, right? On one side, you have the searing heat of the desert. On the other, the frozen world of the Arctic. They could not possibly look more different, but the exact same rules of life apply in both places. Each one is a complex ecosystem with its own intricate web. So up in the Arctic, the whole chain of life kicks off with tiny little algae that grow on the underside of the sea ice. Those get eaten by these little shrimp-like creatures, which then get eaten by fish, the fish get eaten by seals, and then, at the very top, the polar bear, our apex predator, hunts the seals on that very same ice. So the ice isn't just some floating platform, it's the entire foundation of their world. Or, hey, let's jump to a completely different world, a tropical mangrove forest. Here, leaves fall into the water, they feed crabs, and those crabs become a meal for monkeys. See, it's the same pattern again and again, no matter where you look. A continuous, complex cycle where absolutely everything gets used and recycled. But, these natural chains are built on materials that can be broken down, that can be recycled and reused. So, what happens when we introduce something into these systems that doesn't break down, something that just doesn't play by nature's rules? This brings us to a really critical concept: persistence. A persistent chemical is one that nature's cleanup crew, the bacteria and the fungi, they just can't deal with it. It's kind of like throwing a plastic bottle into your compost pile. It just sits there. It doesn't go away. It can linger for years, even decades. And when an organism takes in one of these persistent chemicals, it gets stuck. This is called bioaccumulation. The animal's body has no way to process it, no way to get rid of it, so it just builds up in its tissues, usually in the fat, over its entire life. And this is where it gets really, really dangerous. The effect just snowballs as it moves up the food chain. So look at step 1. A chemical gets into the water. Step 2. Tiny organisms absorb just a tiny bit of it. But then, step 3, a small fish comes along and eats hundreds of those organisms, concentrating all that chemical inside its body. Step 4, a bigger fish eats dozens of those smaller fish. By the time you get to the top predator in step 5, that tiny initial dose has been magnified into a highly toxic poison. And listen, this isn't just some theory from a textbook. This is a true and frankly a devastating story. To see exactly how this works in the real world, we need to talk about a chemical called DDT. So DDT hits the scene in a big way in the 1940s. For about 20 years, this stuff was everywhere. But then, in 1962, a scientist named Rachel Carson published a book called Silent Spring, and it set off an alarm that would literally change the world. Now, it is so easy for us to look back now and judge, but you have to understand, at the time, DDT was seen as an absolute miracle. And in a lot of ways it was. It was incredibly good at killing the mosquitoes that spread malaria and the fleas that carried typhus. It saved millions and millions of human lives. But there was this huge, hidden danger. Scientists started to realize that DDT was the poster child for a persistent chemical. It didn't break down, and it bioaccumulated, working its way up those food chains with that terrifying snowball effect we just talked about. And the fallout? It was catastrophic. The poison wasn't staying put. It was spreading through entire ecosystems, harming animals that nobody ever intended to kill, from fish to mammals, and especially birds at the very top of the food chain. And the most devastating impact was on their young. DDT messed with the birds' bodies, making it impossible for them to produce strong eggshells. The shells became so thin, so fragile, that they would just break in the nest before the chicks inside even had a chance. These broken eggs became this tragic symbol of the damage we were causing without even realizing it.